Welcome to this program where we are going to dive into flip columns for maximum number of equal rows. So you receive as input a matrix of size m times n, and you're supposed to flip the column in such a way that you are going to maximize the number of rows with equal value. What does that mean? Let's say I receive this. Actually, I have 0, 1, 1, 1. 1, 1 is actually a row with equal value because all the elements of the second row are actually 1, 1, which are actually consist of only value 1. So that is one solution. There is no way for me to flip and have a number of rows with equal value greater than 1. So in this case, the result is 1. Now in this second one, we have 0, 1, and we have 1, 0. So let me just write it here so you can see. Like I said, you have 0, 1, and you have 1, 0. So if you decide to split all the elements of this column, what you have is 0, 1 here. And with this, you can see that the element of the first row are actually 0, 0, so they're all equal. So this is a valid solution. And the element here are also all equal, so this is also a valid solution. So that being said, we are kind of aware of what the problem is about. So now the next thing is, how do we approach a solution of solving this? We know the problem. So for us to approach it, we are going to first of all go through an observation. So I'm going to go with an observation like this. I will say, if you have two elements with same value, right? That means, let's say I have this row and this row, they have the same value, right? You do agree with me that if they all have the same value, that means I can flip element and make all value equal. Why? Because if they have the same value, if I flip this, it will change all the element at this line, and at the end of the day, they are still going to have the same value. If they were 0, they can turn to a 1. So what you can say that let's say you want to change everything to 0. That means you are going to say, okay, this one is not a 0, you flip, it will give you 0. This one is a 1, it's not a 0, you flip. So you can, if two rows are actually equal, you can flip them and make them with same value, the two rows. Now there's another observation, which is, if two rows are actually completely different, you can also flip them and have same value. Let's say I have this row and this row, and this row. They're actually completely different. What do I mean by completely different? That means they are different in every bit from the beginning to the end. This one is different from this one is different from this and this and this. If you decide to flip, if you decide to say, okay, let me flip and want to make maybe all element here into 1. This one is a 1, so I don't touch. This one is a 1, I don't touch. This one is a 0. I flip this, it will flip this into a 0. And at the end of the day, this one is going to be 1, 1, 1, and this one is going to be 0, 0. Because initially, they were actually completely different. So, given this, you have two scenarios. A row which is equal to another row can be flipped and have all the value being equal. A row which is completely different to another row can be flipped and have value of the row being the same. So given those two observations, we can directly come up with a brute force approach and implement that. So what we are going to do is that we are going to have, first of all, the brute force approach, which is working perfectly, and after that we are going to dive into one slightly optimization of the brute force approach to have something a little bit better. Okay, I think now we are good to dive into our approach. Okay, so like we said, we have, this is the brute force approach of exactly what we just described. You are taking each of the row, and for each of the row you are looking for the row behind, like under, which can be paired with that row. And we agree that a row can be paired if they are actually all equal or all different. So you can write a function is pair or is same or what you want here. And in my case, I choose to write it as is same, And what I'm doing that is that I'm looping through all of the elements, and I'm counting the number of elements which are actually equal into the first one and the second one, like how many elements are equal in the same index. Now after that being said, at the end, if the total is actually 0, that means they are completely different. If the total is actually equal to the size of the vector, that means they are completely equal. Those are the two scenarios that we need to return a 1, otherwise I need to return a 0. So this now way, for each of the row, this one is going to compute the list of the element that can be paired, the list of the row that can be paired with that one, in such a way that the flip will give equal values. Nice. Okay, so that being said, we can try to run this and see what it will give. Submit. So it's working pretty well. So the solution is working. Now, is there any way of optimizing this approach? Yes, because at the end of the day, we just want to count the number of rows which are same, and by same we mean which are actually completely equal, or two rows are actually same if they are completely equal or completely different. We just want to count that, so we can use a map for that. So what we can do is that instead of having to write a function which is going to compute every time for each of the row, you can just have it one time. So you are not going to need this function anymore. You still need this answer because this is what you are going to have at the end. But you can see that this one is way better than the previous one because you are avoiding recomputing those is same many times, and this one is more cleaner. So this is what my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. Let me know what you think about this. See you tomorrow in a new video. Ciao.